All right, good day. Hope that you're doing well. So in this video, we're going to be going through organic chemistry, and specifically under organic chemistry, I want us to look into isomers, right? So what is a structural isomer? Structural isomer are compounds with the same molecular formula, right? So basically, they have the same molecular formula, but different structural formulae. And we have three types of structural isomers. We have a chain isomer, positional isomer, as well as a functional isomer. So we're going to be going through each of them. Now, starting off with the chain isomer. Now, what are chain isomers? They have the same molecular formula, but different chains, right? So basically, for example, it's important for you to know that with regards to chain isomers, the functional group is still the same, right? Or the homologous series is still the same. This is still an alkane. Its chain isomer is also going to still be an alkane, right? So the homologous series is not affected. So basically here, an example is here butane, which has 4 carbon atoms. Now here, it's just that one of the carbon atoms was branched, and as a result, it was placed here. Now, if I were to make another example, now let me just make an example. Let's say I have this 1, 2, 3, 4. And here I have a double bond, and here I have a branch, right? Remember, your carbon can only be bonded to can only have a maximum of 4 bonds. So here it would be 3. This would be the last one. This one already has 4 bonds, so this one would have 1, 2, 3, and in total there would be 4. This would have 2 to make them 4. This would have 3. Right. Now, if I were to see, right, basically, let me start by writing down the molecular formula of this compound, right? So this is an alkene, meaning that its chain isomer, it's also going to be an alkene, right? So if I were to write down its molecular formula, how many carbons do I have? I have 1, 2, 3, 4, 5, 5 carbons. My hydrogen atoms, let me count them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, its chain isomers should also have the same molecular formula, but the chain should be different, remember. Now, let me try and draw down its chain isomer, which must also be an alkene. Now, if I were to do that, I would say, okay, still have a double bond, 2, 3, 4, and I'm going to make it a straight chain, right? So I've maintained my double bond and I've made this chain to be straight. So now let me draw down my hydrogen atoms. So drawing down my hydrogen atoms, this would only have 2 because it must have a maximum of 4 bonds. This would only have 1. This would have 2. Same applies to the other one. This would have 3. All right. Now, let me write down the molecular formula of this, right? So now I have 1, 2, 3, 4, 5 carbons. So it will be C5. Now, let me count the number of my hydrogen atoms. Now, doing so, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, meaning that this would be the correct chain isomer of that, right? Remember, with chain isomers, they have the same molecular formula, but different chains. And always remember that the homologous group or homologous series, it should always be the same. This here, it was an alkene because it had a double bond. Same applies to its chain isomer. It would also be an alkene, right? So every time, whenever you want to test whether your chain isomer is it correct or not, try to count the number of carbons as well as your number of hydrogen atoms. So if they're equals to the compound that you are given, in this instance, this is equals to that here. If that's the case, this simply means that your chain isomer is correct, right? Now let's move to the other type of isomer. Now, positional isomer. Now, what are positional isomers? These are molecules with the same molecular formula, right? And also, they're in the same homologous series, right? This is important. So they have the same molecular formula, right? Because you see the similarities between your chain isomer and your positional isomer. Same molecular formula, same homologous series, but the difference is the position of the functional group. Now here we are made, they've given us an example with this alcohol, right? So here, the OH functional group is in the first carbon, right? On the other compound, this is placed on the second carbon, right? So it's important for you to know that these two are still the same, right? This is still the same homologous series. The only difference is that the position of the functional group was moved to another carbon. Now, let me make another example. Let's say we have, I just want to make an example with the ketone, right? Let's say we have this. Right? Now, if I were to write down my number of carbons, so this should have a maximum of 4 bonds. So my number of hydrogens here would be 3. This is fine, it already has 4. So here my hydrogen atoms should be 2. Same applies here. On the last carbon, they are going to be 3. Now I'm saying that with regards to your positional isomer, right, we are only changing the position of the functional group, which is this, right? This is our functional group. We're only going to change its position, meaning that we're going to place it on another carbon atom, right? And if I were to do so, let me start by writing my carbon atoms, 1, 2, 3, 4, 5. Now, if I were to do so, I can place it here in the middle. Now, let me write down my number of hydrogen atoms. So this would have 3, this would have 2, because it must be bonded to 4, right? It has a maximum of 4. This already has 4. This would be 2, and the last one would be 3. Now, let us try and see if the molecular formula is still the same. The homologous series is still the same. This is still a ketone. Same applies to this. It's still a ketone. Now, let us confirm if the molecular formula is still the same, right? This is how you confirm your answer. So here I have 1, 2, 3, 4, 5 carbons. Now, let me count my number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 1 oxygen. So now, let me do the same for my other compound. 1, 2, 3, 4, 5 carbons. Now, let me count the number of hydrogen atoms I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I only have 1 oxygen. Now, can you see that the molecular formula is the same, right? Same applies to your homologous series, is still the same. This is still a ketone. What is the difference? It's the position of the functional group, right? Instead of it being on the second carbon here, we placed it on the third carbon. Now, the last isomer that I want us to have a look into is your functional isomer. Now, what is the difference between your functional isomer and other isomers? If you noted, right, with regards to other isomers, the homologous series remain the same. But with your functional isomer, your homologous series is different, meaning that if you have, for example, if you have a ketone, its functional isomer won't be a ketone, it will be something else. So this is the difference between your functional isomer and other isomers, right? They are in different homologous series, right? So now these are molecules with the same molecular formula. So the molecular formula is still the same, right? So your molecular formula doesn't change, but they are in different homologous series, which is what I was explaining. This is the only difference, right? So the homologous series would change. Now, there are two types of functional isomers that you need to know about, right? So what are those? These are ketones and aldehydes. And the last ones are your carboxylic acids as well as your esters. Now, these are the two, right, functional isomers you need to know, right? So your ketones and aldehydes as well as your carboxylic acids and esters. Now, let us look into an example, right? So can you see here, right? Here, you are given a ketone. So you're given a ketone. And what happened is that they shifted this functional group to the last carbon atom, right? As a result, remember your carbon atom should have a maximum of 4 bonds. So here it's also bonded to your hydrogen. So this, remember, is the functional group of your aldehyde, right? So basically we move from being a ketone to an aldehyde. Now, let me try and draw this here, or let me make another example with regards to these two. So let's say I have this 1, 2, 3, 4, or let me make them 5, 5. And this is my ketone. This is its functional group, which is here. Now, let me draw the hydrogen atoms. Now, what's going to happen is that we're going to take this functional group and we're going to place it either on the last carbon or on the first carbon, right? So every time whenever you have a ketone, it's either you take the functional group to the first carbon atom or the last carbon atom. And as a result, you would be forming your aldehyde. Now, let me put it in the first carbon atom. So I would have 1, 2, 3, 4, 5. So as a result, I'm going to put the double bond here. So remember, your carbon should have a maximum of 4 bonds. So 1, these are 4. This only needs 2. Right? This only needs 2. And this needs 1. So as a result, can you see that this right over here, this is the functional group of your aldehydes. So we move from being a ketone in this instance to being an aldehyde. And remember, how do you go about doing that? It's either you're going to take this, O functional group. It's either you're going to put it on the first carbon atom or the last carbon atom. All right. So like if you were to find the molecular formula of both, it should be the same. So here I have 1, 2, 3, 4, 5 carbons, C5, hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have 1 oxygen. So doing the same here, I have 5 carbons, my hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have 1 oxygen. So can you see that the molecular formula is the same, right? Now let me make an next example with regards to your carboxylic acids as well as your esters. Now let's take this example of your propanoic acid. And we're going to find its functional isomer. And remember, the functional isomer of your carboxylic acid would always be an ester, right? So let us try and apply the very same principles here. So what is the functional group of your ester? Remember, your functional group of your ester, you have an O, right? And here you have your carbon atom, which should be bonded to oxygen. And here you must have another carbon atom, right? So this is the functional group of your ester. Okay, now let me go about doing the same. So I'm going to start with putting my oxygen here. And I know that this oxygen, it should be bonded to 2 carbons. And here I should have the double bond of the O. All right. Now let me try and rearrange my carbon atom. So here I have 3 carbon atoms, meaning that I'm only left with 1 to arrange. Right. So I can either put it here, or I can either put it this side, or I can put it that side. Right. So it depends on you. Now let me do an example of both. Let me start first by putting it this side. So as a result, there I would have 3 hydrogens. Right. Now, if I were to write down the IUPAC name of this, I'm going to first start by, so I'm going to start with this first part. I have 2 carbon atoms, right? So as a result, so I have 2, this would be ethyl. I have 1 carbon, it would be methanoid. Now, let me count my number of carbons, 1, 2, 3. So I'm trying to write down the molecular formula for this. I have C, 3, my hydrogens are 1, 2, 3, 4, 5, 6. So C3H6, and I have 2 oxygens. Now, let me do the same for this, which I was given initially. So let me underline this. So here I have 3 carbons. My hydrogens are 1, 2, 3, 4, 5, 6. And I have 2 oxygen atoms. Right. Now, let me write down the same, right? Carboxylic acid. Remember, I said on the second carboxylic acid, I'm just going to put the carbon on the other side, right? So I said, okay, start with your functional group. And this time I'm going to put the carbon this side, right? So remember this other carbon which is here, it should be bonded to your oxygen with a double bond. Now as a result, it should have a maximum of 4 bonds. I'm going to put 1 hydrogen here. So these would be 3. Now, if I were to write down the IUPAC name of this, I'm going to start with naming this part, right? I have only 1, so it would be methyl. Here I have 2, right? So it would be ethanoid. Now, let me write down the molecular formula of this. I have 3 carbons. Let me count my number of hydrogen atoms. So I have 1, 2, 3, 4, 5, 6. And here, my oxygen, it's 1, 2. So can you see that this is the same as the others? All right. That will be all for this video. Remember, if ever you have any questions, always feel free to reach out.